This is not particularly related to DevOps process, but out of the topic, we need an example in a real world environment so everyone can easily understand and relate how this is going to be an impact or important. Let's consider we are all of us are using a mobile phone. So a new mobile phone to come into the market. So it it usually takes 2 to 3 years to start from the designing an RTL level or hardware level phase, and then testing it, and then coming to the market. Okay, so actually the process starts like this. If a new cell phone needs to be introduced in the year 2027, right now the hardware and RTL design phase should have been started. Okay, and once it is started, then all the design ideas, compilation ideas, everything will be done. Then the major important task here is the testing phase. So you could see, for a single cell phone to come to the market, you almost need close to 2 million cases, which needs to be tested and regressed very rigorously to make the final product, which is applicable and ready to use for end user. Okay, so let's say these many cases needs to be tested in the middle, and after once it is tested, the mobile phone goes to the fabrication place where the chips and all will be designed and fabricated, and someone finds, say it's like after the 1 year timeline, someone finds a mistake in the initial RTL design or in the initial first design code where it is written. Almost you have completed 1 year now. Now you wanted to stop everything, fix the first problem, and then again you need to start from the beginning. So, like let's say 2026, you found an issue, then you need to again spend 2 to 3 years again to complete the cycle and enter into the market. So instead of your launch in 2027, you will be forced to skip to 2028. So these are the drawbacks or uh, hectic ways, hectic measures which stops us to be on time, uh, which is stopping our effectiveness, which is stopping our efficiency, all these cases. But we can say that, okay, we are not effective, we are not efficient or on time. This is a coding world. We can, okay, we as an engineers or an academic person, someone may be okay with it. But once it needs to be in the customer end, once it needs to be in uh, the real world product which the end users are going to use, at that time this kind of acceptance is never acceptable in any of the software industry or any other industries in the world. Okay, so to overcome all these cases only, what can we do? Whether we can paralyze the entire design process, entire testing process, entire uh, delivery process, so that everything becomes faster and in time, in efficient, in the expectations of the customer, in the expectation of the company who is producing that. So those are the basic steps which leads to the concept of this CI/CD principles in the DevOps. Okay, so moving on, this is the real coding word example who is using these pipelines and how they are going effectively using these pipelines in the very big industries. Okay, so starting with big giants like Netflix, the Facebook company, and the Amazon, all of them are using this CI/CD pipelines, and they have developed best in class world, best in class pipelines, so that nothing can stop them from delivering, and nothing can stop them from innovation, nothing can stop them from on time coming to the real world. Okay, so these are the simple examples of who is using which one. So Netflix is having the one of the most sophisticated CI/CD pipelines in the industry, in the current industry. Okay, they employ a microservice architecture with continuous delivery to ensure that new features and updates are developed rapidly and without any downtime. So that is their major advantage. Okay, so how they are achieving this? They are achieving using two of the CI/CD pipeline structures called the Simian Army and the Canary development. Okay, so what a Simian Army is, this is a tool which is used in their production. Like whoever is going to write a code, they used to write it on the Simian Army. Okay, so once the code is ready, they are using this canary development. So what will happen is, even if one of a Netflix employee is writing a small code, it may be a very simple enhancement of the original Netflix website. But what will happen is they will first integrate that code and deploy that code in a first small set of users. Make sure in that code is not crashing or that the code is not breaking anything in that small subset. They will monitor it, and once they are confirmed, once their guidelines are met, they will roll out to entire world. This is how internally Netflix is upgrading each version of its software. Okay. Similarly, Facebook is also doing the similar things using the continuous deployment and Sandcastle. So this Sandcastle is the build and test infrastructure which is currently best in class with high parallelized coding manners, and everyone is trying to get this license in the to get a better CI/CD pipeline in their entire entire work. Okay. Next comes Amazon. Same, Amazon also using all these pipeline technologies to improve to update its various range of services, right from the platforms like AWS and other websites, and they go with a single click deployment process. So whatever changes they are doing in a single process, that will be given to the entire world as soon as it is ready. So these are the current very good um, CI/CD pipelines which are currently used in market by various big tech giants. Okay, so give with all these introduction, let's go to uh, the basic principle of what is this CI/CD, how it is coming under our DevOps banner, and how it will be used for our understanding and our project improvisation. Okay, so what is happening under the DevOps banner? These continuous integration and the continuous delivery, these are the two methodologies. Okay, and these two methodologies will be combined together to form a development and operation. So DevOps, you might be already aware of. DevOps is the combination of the world between developer and the operation teams. So the DevOps team will be interacting with both the development team and the operation teams to get all the code stitched in and release it to the customer. So this is how the entire concept of the DevOps panel. Okay, so one so the infrastructure, like how this is going to be built, how this is going to be tested, and how it is going to be deployed in a real world application or a real world customer environment, that forms the major work involved in the DevOps career using this entirely automated pipelines. Okay, So using this pipelines, each, not only the DevOps team, each developer, they can update the code, and the updated code can be provided for testing and deployed right away. No need to wait for any other any other timeline. So once they update the code, they can give it to test. Once it is tested properly, it can be deployed right away. Okay. And because of this, the major advantages that is happening is the code releases are occurring very quickly. And say, for example, we have launched one particular software of version 1.2. Now, there is a particular glitch in the software. We need to improve it, or we need to fix the glitch and make sure that our software is not going to face this glitch anymore in the future. We can easily update only that glitch, test it locally, and deploy it immediately with a new version called 1.3. So our code releases will be very quick using this pipeline approach. And the downtime, say, for example, when you are moving from 1.1 or 1.2 to 1.3, our software will not be having any downtime during this process upgradation. Okay, everything should be taken care of by a good pipeline. So that is the basic introduction of this pipeline. Okay, so what is the, as I said, what is the general definition is a flexible DevOps workflow that is centered on a regular and dependable software delivery procedure in the continuous integration, continuous delivery pipeline. Okay. Okay, so this is the basic definition of what is this pipeline means. Okay, coming to a software life cycle, how a customer will be, once the customer has given, I want this particular product, or I want this particular website to be developed. What are the things happens in the traditional approaches? First, we need to write the code. That is that work belongs to the every developer who is involved in that project. Then that code should be integrated with all its requirements. Say, for example, you are writing a code in Java, all its plugins should be integrated together, and you need to create a build. Once that build is ready, you need to run before giving to it to any customer, or before giving it to the real world web application. You need to do all the testing, and we need to, once all the tests are done, we need to deliver them as a single releases. And once all the releases are gone to the customer, then we need to check if we can do any other modification in the program. So this is the old life cycle development of this so writing a code and delivering a project. Okay, so this is the linear approach. To overcome this, we are getting the CI/CD pipelines. Okay, so here the primary goal is to automate the entire software development lifecycle. No manual interaction should be accepted. So because of this, entire process is automated. So the life cycle will be uh, totally, the software development life cycle should be totally autonomous. So that is the major principle of this pipeline. Okay, and this pipeline will be covering many aspects in the software development, like as I said, from writing the code, running the test, and once all the tests are complete, we need to deliver to the customer, or we need to deploy it to the web application. So all these things will be should be taken care by the pipeline. Okay, so this is how the simplicity of getting that automation in this pipeline helps in the development cycle of any software. Okay. Okay, and now this pipeline, which is encompassing all the software development cycles, okay, should be collect all these um, stages are put together. That is known as the CI/CD pipeline, and we will be getting uh, improved time efficiency. This by making all these processes autonomous and reducing the manual task as far as possible in this case. Okay, so once we are covering all this topic, then the productivity of the delivery team will be improved, and that is always the main goal of the DevOps cycle. Okay, so coming back to CI, what is continuous integration? Okay, so in the software development process, the developer will be writing their code and merging their code into the common repository. So not only one developer, there will be multiple developers doing the coding. And once all of them are assigned a particular task, everyone will be writing their code independently, and they will be merging them into the common repository. So once this code is ready, then now we need to do the automated build and testing. So what is automated build? As I said, you are writing a code in a Java or a C++, then all these other third-party applications, third-party tools, third-party libraries, plugins, everything should be integrated, and you need to be ready to be creating a build which should be able to work in the customer environment or any environment without any other dependencies. So that process is called creating an automation build. And once that build is done, we need to test that build and make sure it is not crashing, or it is not it is a bug free, or it is not having any other open glitches which is available, which can be detected easily or remotely. So all these things should be done. And once this build is ready, then we will know what are the how this build can be used, whether it can be used as an automated component, such as like whatever we are doing here, like a continuous integration approach, or we will go with the old cultural approach of linear approach. So we need to identify that. And once all these things are identified, then the major goal is we put all these process into a integration pipeline, and once this all these cases are put in the integration pipeline, so this is the entire process of storing the CI pipeline. Okay, so what is the major goal in creating the CI pipeline is, first of all, if there are any defects or any bugs that can be easily found in the very early stages of the development itself, and it will not be going to the customer environment at any cost. And once this is done, that itself improves the software quality and the time taken to validate and make sure our software upgrades are very good, neat, and clean in this approach. Okay. Next comes what is continuous delivery. Okay, so once the integration phase, that is writing a code, building, and testing is done, now we need to put it under as a repository which is used by the customer, or it should be deployed as a web application to the whole world. So this is process is known as continuous delivery. Okay, so this CD takes over during the last stages of code. That means once the code has been written completely and tested, and all the build is created by the CI process, then it can be packed with all the customer environments, and it should be ready to be deployed or delivered at the customer site. So this process is called the delivery process. And once this process needs to be executed, the infrastructure to integrate and deploy should be highly improved, and that concept is covered by CD. Okay, so once the program is created using CD, that can be delivered to the production or any moment. Like so the once a program is completely ready, given ready by the CD process, then it that no wasting of time, it can be going to the production, and then you have the option to manually select, okay, the process is ready now, I need to manually deploy it, or I will use the continuous deployment to make it all the process automated. So that those decisions will be made, and that is how the CD will be completing its stage. Okay, say the same concepts applied for delivery. So what is the difference between delivery and deployment here? Okay, so delivery is you have made a code, and you have made bundled it with all the platforms, infrastructures, and environments you wanted to bundle, and you give it to the customer. The customer will be using that on their own in their environment, and they will develop something out of that. That is delivery. And what is deployment is you directly give the code after you deliver, you directly give the code to the real world, like the end user who is going to use. Say, for example, in case of a website, you directly publish that website. So all any end users who is accessing the website will be using that using it. So this is the deployment. So what is the difference between CD delivery and deployment is whatever happening in the continuous integration is same. Like you need to write the code, you need to test it, and you need to build it and make it ready, the code ready. That is the continuous integration phase. That is no things. Once it is done, in the continuous delivery, you will do the acceptance test, and you need to deploy to the customer repository. Like you need to deliver it to the customer environment. Okay. Once the customer takes that delivery, they will see how they can deploy it to the real world, and they will have their own test smoke. We call it as a smoke test to make it to make it usable, really usable for the end user. And in case of continuous deployment, you need to take care of everything from acceptance testing, deploying it in the production, and testing, monitoring. All these things should be taken care by the DevOps team itself. So that comes under continuous deployment. Okay, so this is the entire anatomy of what I have discussed till now. Okay, so here, as you could see, initially a code is written, and all the related codes, that means all the third-party applications, third-party libraries, plugins, everything are put together. Once the code and all these related codes are ready, you commit all your changes. So that is where these developers work. Once the code is ready and bundled correctly, now you need to build it, create unit test, and do all the integration testing. So that forms the CI pipeline. So once the work of CI pipeline is done, then in the CD pipeline, you review all the builds. Now you put it, okay, what are the changes available in each build? You put it as a stage-wise approach, uh, like a version-based control. Let's say there is a version from 1.0 to 1.1. You need to put the staging like in 1.1. What all the differences has come? What are the bugs has fixed? And how it will be affecting the real world solution. So all these things should be tested and put it in the production stage. So this is how the entire process of this pipeline, the backbone of this pipeline structure, we need to develop in the DevOps process. Okay. So as I said, why this pipeline concept came, like we can use it as a linear approach. Don't need to make it complex, or don't need to make it autonomous and make our life complex. But why it is important? So these are the 6 key points, which are the major reasons for transition from the linear method to the pipeline method. Okay, so here the first thing is, as I said, it should be working effectively and efficiently as much possible as possible. Second, it should reduce the time consuming effort which is happening in the manual development life cycle. Third, the automation process, it will be one, as you make a process automated, the chances of human mistakes will be drastically removed. So that is the beauty of automation. Once you make a process automated, the human mistakes will be reduced as much as possible. So then the fourth one is there is a lower risk of build breaking process. So once the CD pipeline, as I said, the CD pipeline will be monitoring and staging all the builds. It should make sure that none of the builds is crashed by any of the code change. Okay, so there is no way a faulty build comes out of the CD pipeline. So that is how CD takes care of all the building process, and always there will, our build will not be breaking. That means our tool or our software will not be crashing at any point of time. That should be that can be easily attained by this pipeline approach. Okay, so, then the last two things are let's say there is a software version upgrade from 1.1 to 1.2. We don't want to wait for major updates, like major changes to be happened in the software. Even if it is a small change, even if it is simply you are changing a button structure or button behavior, even that thing also can be integrated and deployed so that everything is faster. More than faster, what is happening is, once it is deployed to the end user, they will give the feedback. Okay, this I'm saying an example of a button in the website. Let's say they are having a button to with a link to something. That button is not working fine. That is the end user command that can be given to the developers as early as possible, and they can rectify that as yearly without leaving for the faster for customer satisfaction. So all these things can be made interactive, and that makes all the process effective, efficient, and less time consuming. So overall, we are having a shortened software development life cycle. So that is the major final achievement we will be having. So more shortened software development cycle, more softwares will be developed, more upgradations will be done. So this is the one of the major reasons for having these pipelines. Okay, so how to build a pipeline? What are the basic fundamentals you need to consider while building a pipeline? Okay, so these 8 steps are the major cases which we have found to be useful in creating a good CI/CD pipeline. Okay, so first thing is a single source repository. I will explain about each of these points in the coming slides. Okay, so the first is a single source repository. Second is recurring check-ins, like more frequently you do check-ins to the main branch. Third is the automated builds. Fourth is self-testing builds. Like as I said, the build should not be breaking at any cost. So it should be able to self-test itself and make sure the build is ready for the customer environment. So those comes under the self-testing builds. Recurring iterations. You can do these process as many times as you want. You can make a new change as many times as you want and come back to this iteration. Stable testing environment. So you need to have a very good testing environment. So make sure this pipeline is able to test all the codes in a very good environment, so that once it goes out to the customer or the real world application, it is not crashing or it is not having any issues in the real world. So everything should be captured in the in the testing environment itself. So once we are doing all these things, we will get the maximum visibility of how our software can perform, and it should be always easy to deploy at whatever the time we want. Like it should be always available to be deployed into the customer case or the real world case as soon as it is available. So all these fundamentals will be taken care to create a better pipeline. Okay. The first thing is single source repository. Okay. So as I said, a code will not be written by a single developer. It will be written by multiple developers at the same time. Okay. So we need to have a better source code management. Okay. So everyone should be, say, for example, there is a source code, and the copy of the source code is available to all the developers. Okay. So each developer will be assigned one particular task or a specific enhancement they need to be bringing it on. Okay, so not everyone can be working on the same source code itself. They need to take a copy of it. They need to add new code changes or update any code changes in their own copy and put it back in the main source code. So this is how it should be worked efficiently. Or else, if everyone, say for example, instead of having a single source code, everyone is having their own source code, and it comes to the DevOps team, people to integrate all. So let's say there are 10 developers, they are all of the 10 is having their own version of the code. Then the DevOps people need to collect all these 10 codes, and they need to merge and integrate and get a single source code. And if something is missing, okay, one of the developer is using a function, and another one developer is also creating a new function, but for different purpose, there comes a conflict. So to avoid all these things, there should be a better source code management. At the same time, all the source codes and files and scripts should be available to all the developers, and so all these things are managed by a single source repository. So what are the single source repository which are currently available in market are like Git, one of the thing, Perforce, that is another one repositories. So these things will make sure this is uptime. So once you are building a pipeline, it doesn't mean you know one particular software or particular tool that will create all the things. So to create a pipeline, you need to you need to understand what are the various other tools. Say for example, to create a pipeline, to write a code, there are several source repositories available in the market. You need to pick one which is best suiting for your project development also. So that is enough. Then for building, you need to take there will be several compilation tools. You need to pick a good compilation tool for your project, and also for testing environment. For example, there are several cases like Selenium or other cases. You need to pick a thing. So you need to have an idea of different tools, how it works, how it can be integrated into a single project to make our project deliverable or deployed to the real world in application. So this is the major requirement. Okay. So as I said, single source repository is like nothing but how you manage the source code, and the source code is not including not only the code which is written by a developer. Like let's say you are writing a main function and having different class APIs and other functions, that is not only the single code. You need to take care of all the third-party application, third-party licensed plugins, third-party libraries which you are using. Say, for example, in C++, you will be using standard libraries. Apart from standard libraries, there will be some more libraries also which is available in the market, which you can use and make your code efficient. So you need to take all these together, like the source code, what is the entire architecture you need for the source code, all the libraries which is required for the source code to work, and all the properties of the libraries, and what are the versions. Say, for example, different versions of libraries will be available. You need to take care of all the versions and make sure all these things are uh, uh, stitched together in the single repository which you are going to create for the project. Okay. Now, once you have identified, okay, this is my going to be my source code repository. Now everyone will take a copy of from the source code, they will be making their changes, and they will be putting back into that main branch. So once everyone is merging their check-ins into the main branch, we should make sure that all there is no conflicts happen between the code of first developer and the seventh developer. So everything should be merged correctly. And for what is the beauty of continuous integration is, say, for example, I will say an example of Perforce. In the Perforce, one of the developer is checking in their code, let's say version 1, and another one developer is checking in another code, that is version 2. Then our Perforce, what it should do is, it should create a build separately for the version 1, and also it should create a build separately for version 2. Why I am saying you this is, let's say the first developer had missed something. He has a bug in his code, but he has checked in the code into the central repository. And without knowing this, the second developer has also checked in their code in the central repository. Now, when we are compiling the entire repository, we will get errors. Then we don't want to wait until the first developer to fix his error. Okay, so we need to make a build only including the first developer changes, and also a second build which is including only the second developer changes. So if the first build is crashing, you discard that build. You say that developer, okay, you revert your changes, and we will go with the build which is done with the second developer changes. So all these things should be happening. So in the integration phase, there can be multiple check-ins. Multiple check-in means the software is having multiple properties enhanced. So that is the beauty. So multiple check-ins, and do all the check-ins into the main branch. So once the main branch is all the check-ins are done into the main branch, it will be always clean, and it will be able to create a build at any time. Okay, so yeah, as I said, the next one is creating the builds. Once all the scripts, all the codes are done, you need to create an automatic script that will be uh, taking all these codes, as I said, all the codes, database scripts, and any other third-party applications. All these things should be merged together, and you need to create a bundle of a tool, so which is a build that is ready for going package, that is ready for packaging and getting it used by the customer. So that kind of customer environment based packages will be getting ready using these builds. And as I said, once you need to create a build for every change. That means every check-in you are doing into the main source directory, and make sure that multiple check-ins are not making your work difficult. It should be multiple check-ins. That means there are multiple builds. If one of the build is having an issue, then that build should be discarded, and the final build should be always a bug-free, glitch-free build that can be easily given to the customer. Now, once this build is created, you need to start testing using this build. Okay, so first thing is the build should not fail. That is the basic static testing everyone will be continuing. So once the testing is done, so we need to make sure the security of the code will be maintained, and all the customer all the customer environmental customer changes are fixed. And once it is going to the real world application, it is not going to crash. So all these testing should be done beforehand itself in the CA process. Okay, so as I said, this is an iterative process. Like once developer is doing something, continuous integration is creating the build. It doesn't stop in a linear approach. It will be recurring continuously again and again, so that the more issues are coming, uh, the more changes are coming, we are quicker to make a big software with all the necessary changes and modifications which is required to go to the customer. So all these things should be happening recursively. That is the major one of the fundamentals again. Then stable testing environment. Okay, so whatever testing you are going to do in your machine, that is fine. But we need to always have an environment that makes sure the changes which I have done is not working good only in your machine, but it is also going to be work in uh, all the machines which are available outside your organization. Say, for example, it may be working good in your laptop. Okay, but once you deliver it to the customer laptop will be having different configurations and different plugins or other cases. So it should be working good in the customer laptop also. It should not be having a crash in the customer laptop. Okay, so those things should be taken care. We should not have a testing environment only based on our laptop or our system or our server. We need to put and create an environment which will be widely used. We can have different versions of servers, and we need to test it in different versions parallelly, and make sure all the environments our build is stable. Okay, maximum visibility. So as is every developer, they have created some changes. They have put it in the central cost repository, and the build is getting ready and it is tested in the good environment and everything. But all these changes, say for example, I have did some changes. At the after some time, I having a doubt like, okay, I'm not sure about the changes, so I need to go to that final build. I need to figure out, okay, this my changes is integrated in this particular build. I need to revert that build. That all these things should be making it visible to all the persons in the developer team, so everyone can be handling the delivery very good. So that is one of the fundamentals which need to come. And as I said, once the code is coming out of CI/CD stage, it should be always ready to be readily available for deploying in any of the customer environment or the real world website applications or any other servers it needs to be go on. So it should be always available to take in. Okay, so these are the major fundamentals which are needed to create a better CI/CD pipeline. And the how can you make a a good pipeline? So what are the basic understanding is from right from once all the build is completed, once the build is ready and it is going ready to deploy, so the time taken between the build readiness to deployment should be always happening within 1 hour. If it is not happening within 1 hour, then it means our pipeline is not a good pipeline. We need to make sure our automation should be faster to make all the testing and deploy it everything within an hour. That is the industry standard which we are currently practicing. So whatever the code um, uh, which needs to be deployed in a end user application, that needs to be done or happening within 1 hour. If that is not the case, then we need to uh, make sure our pipeline is still more effectiveness. We need to make sure all the steps taken to get that done. Okay. So, and also we need to continuously re-evaluate our pipeline strategy also. We should not, once a pipeline is created, we should not take guaranteed, okay, this pipeline is done. We can use this pipeline for the entire software delivery. No, on a timely basis, you need to make sure all the stages in your pipelines are working fine. You need to improve that. You need to make more automation. You need to make more optimization. So all these things needs to be done and continuously improved in the for a good pipeline to be everlasting for a longer period of time. Okay. So yeah, these are the basic. Um, this is the basic summary of whatever we have uh, described as the fundamentals of pipelines. Okay, so as the first step, you will be creating the build from the different code changes which are coming in. Second, you need to make sure the infrastructure, like you need to make sure the build is having all the infrastructure which is not working not only for your system but also available for all the customer and real world application. So that infrastructure should be taken care of. Then you need to do the testing of your build with these different infrastructures. Once the testing is done, you need to do the release. So this is the major case of the pipeline, like how this pipeline is going to be really effective. So the release is one of the important tasks. And once the release is done, okay, the customer or end user is using the upgraded version of the software, we need to monitor it. That comes under validation. Okay, so the more you monitor, the more you will come to know, okay, our upgradation is going smooth. So you can identify if there is any other issues found in the monitoring, then you will come back to the build stage and continue the cycle repeatedly. Okay. So yeah, as I said, first thing is build the source code creation and packaging. The second thing is infrastructure. And the third thing is testing, which is having different kind of testing like integration test, soak test, load test, regression test, and build centric test. And the next thing is release. As I said, the release is the actual deployment process. So this is the major bone, major spinal cord of the entire pipeline. Okay, so this needs to be handled correctly. Currently in market, there are three different strategies which are used for deployment. One is the rolling deployment, second is the blue-green deployment, and third is the canary deployment. Okay, so what is rolling deployment? What is happening is there is a software which is already available in the market. What we need to do is we need to temporarily make that software. We need to temporarily shut down the software. That means, say that for example, there is a website. Let's say there is a banking website, net banking website. For 1 hour or something, as I said, for 1 hour, we need to make sure that the website is not working. We need to give a message like this website is shut down for some temporary reason for upgradation. So we need to wait. So the old software or old website, which is already available in the web in the real world, should be stopped, and all our sequences should be uploaded in the original server and deployed. So in this time, as I said, the 1 hour where we are shutting down, the entire application is affected. Like no one can use that application, And once all our integrations are done and we have deployed every changes into the final integration, then again the program will be made live and everyone can use the software. So this is called rolling deployment. Okay. Second thing is blue-green deployment. Say rolling deployment seems to be easy. Like you stop the software, update it, and make the software live again. That seems to be easy. But not every time every software can be shut down even for a single second. Okay. The same any net banking, if for 1 minute your net banking is stopped, that means you cannot do any of the transaction in that 1 minute. That affects the major economy. So you cannot take all kind of risk. In this case, we will do the blue green deployment. Okay, the blue green deployment, there is what is doing is we will have two versions. Okay, the old version, which is we will call as green version, that is the old software is still live. You won't touch the old software. Say for example, in a particular server, you are hosting two softwares. You are making two versions of the software. One is the old version, that is green version, and another one is a blue version. The old version is still visible to the user, the end user, so they can use it. But all your integrations will be happening in the blue version. Okay, so once all the integrations are happening inside the blue, then the blue is we make sure the blue is ready to go. Then we will make blue as green and then delete the green. This is how the process. Okay, so this makes sure that we are not stopping our software anywhere, anytime. It is always live during the upgradation. And once the upgradation is complete, we make sure the new changes are also coming into the changes without any impact to the real world customers. Okay, so that is this blue green. So one disadvantages here is we need to have two different versions. Maintaining a two different versions is like a little expensive process. So that is one of the disadvantages of this blue green deployment also. Then the last is the canary development. This is one of the new deployment which is recently becoming a hit in all the software development companies. Okay, so what is happening is there is an upgrade. You will give that upgrade only for a limited set of users. Say for example, as I said, Netflix is the case example. Let's take an example of Netflix. So, or there will be, let's say there are 100 subscribers. Okay, so you want to upgrade your website to the next level. What you will do, only for 10 subscribers you will make sure you have upgraded. Okay, so remaining 90 subscribers will be using the old version. Then once you are confident, okay, this 10%, there is no issues, everyone is using the upgraded version correctly, then 10 should be made as 20, 20 should be made as 40, 40 should be made as 80, and last to 100. So gradually you are increasing the upgradation for the end customer, stage by stage. Like you are not putting the upgradation for the entire users at one go, but you are doing it in a gradual step-by-step process. So this reduces the cost of, say for example, there is some defect in the deployment. Only in the first 10% usage itself, you will come to know while monitoring, okay, this upgradation is not going good, we will revert back the changes. So these all comes under the canary deployment. Okay, then as I said, validation. Once all these things are deployed, it is not, our process is not completed. We need to still go and monitor our upgradations are good, our whatever the changes we have done are effective, and we need to get all these monitoring results and give the feedback to the developer. So this is how the cycle continues recursively. Okay. So yeah, the speed, reliability, and accuracy. These are the characteristics which are needed for the good pipeline. And these are the best practices. Like there are some best practices to make CI more efficient and CD more efficient. So first thing is commit early and commit often. You do changes very often. Even if it is a small, as I said, even if it is a small change, do go ahead, do it, and commit your changes into the central repository. And you keep on optimize the pipeline stages. That means you reevaluate and make the pipeline stages more automatic, and make sure all your builds are getting fast. You should not waste time on creating a build. And you also make sure if there is any failures, then that should be easily catched, and that should be not repeated in again in the pipeline. So that should be taken care of. And one of the major important cases, make sure that the test in whatever the environment in which we are testing is in line, or we are creating a better test environment as it is in the real world application. Okay. Similarly for CD, these are the best practices. Like you can start wherever you want. You don't want to start, okay, I want to have a big code and then only I need to put the deployment. No, even if it is a small change, start deployment, you can put it in the deployment pipeline. Okay, so this increases, more changes are frequently going out very easily. So the software is easily upgraded step by step without any major waiting time. Okay. So first thing, then understand the best continuous delivery tools. Like there are several delivery tools. I will just explain them in the later slides. And we can track and streamline all these pipelines in the automations. All these things can be done very effectively. And we will keep monitoring. So the monitoring is the main purpose, which will be increasing the visibility for the developers if there are any issues in the software. And once that is done, efficiency will be improved. Okay. So to reach this, there are some challenges also. Like not everyone will be coming to know what are the environment limitations, environment which is used in the real world application. Say, for example, I am a small company. I am creating a software. I may not be having all the real world environments available in my small company. So that is one of the limitation. Second is, as I said, for every third party application or every third party plugin, there are different versions. So we need to have all the versions included in our pipeline. And there is a lot of cross communication, cross team communications, which will be happening in the pipeline. So you need to manage all these cases. So these are some of the major challenges used in the creation of pipelines. Okay, so there are other challenges are how good you are going to create a test suite, how how say for example, you need to create a test suite not only for the own environment, but for other environments. So all these things, the manual database deployments, unplanned downtime. Say for example, if there is a downtime which is unplanned and people are complaining about that, that is again a problem for the pipeline. Difficult roadblocks, like roadblocks will be many while creating the pipelines. We need to make sure we are not missing any metrics which is used for the software upgradation and the environments. Okay, so this I am leaving it. This is one of the expert advice of how to create a good pipeline and how to manage it. So these mostly covers whatever I have covered in the previous slides. Okay, so the pipeline should be always consistent. It should be scalable to meet any job demand, and it should be fault tolerant. It should not be it should not be it should be reliable. That is the case. And once you create one single pipeline, that should be reusable for other cases also or other projects also. And the security should be taken care. Like any of the security threats and other things should not be impacting us. Okay, so first thing is how to create the pipeline. Once you create a pipeline, how you are managing it. Okay, so that for that you are having several tools which are currently available in the market, and for academic purposes there are several tools which are available free also. So that is a good advantage. So Jenkins, that is one of the best tool which is used for CI/CD pipeline development currently. Azure develops. I have given the. I hope this slide will be available for all the participants, so you can go to the link to download any of the tools which you are comfortable with and start working on as a hands-on. Okay, so Jenkins is the currently available tool. Azure DevOps is also one of the tools. Earlier it was known as VSTS and CodeShip. So these are the source where you can download these tools also. So you can use that. Okay, so now quickly I'm going to give an introduction like how I am going to create a pipeline and how I am going to manage it using a Jenkins tool. Okay, so what I am going to do is I am going to create a web application, a simple website to get two numbers and add, subtract. So mathematical application, web application. So I am using Java to create the web application tool, and the build tool which I will be using to create build is Apache Maven. And as I said, source code management is important. So GitHub is the source code which will be used. Selenium is the tool which is used for testing. And for all these continuous integration, I am using the Jenkins tool. For deployment and monitoring, I am using Apache Tomcat and Jenkins plugins. Okay, first step is, as I said, every developer or anyone should write a source code. Okay, so once in this case example, whatever I'm having is a source code for a simple for calculator and web-based calculator. Um, Okay, so I will take all the documents like this. All the main functions and all the source codes will be I will be making it ready. Okay, so the first thing is write the source code. Then you configure all the, as I said, right? You need to configure it all the cases, whichever is all the plugins, whichever is required, and you need to create an you say if you are using any IDE, you need to configure it and get it done. So all this is the first step. Okay, so now the first concept of CI/CD pipeline, mostly CI pipeline. You are having you need to create a central repository. So in this case, what I'm doing is I'm creating a repository here, a Git repository, and whatever the code I have written, along with the plugins and other third-party libraries, I am merging. I am pushing it here using. I am pushing it into the central repository. So as I said, there will be a single source code repository. I am taking a copy of that, making all the changes, or I am creating a new code itself. Then I am integrating with all the plugins and put it back in the source code. So this is how the first step works. Then I will go to the Jenkins. You can create your own Jenkins admin user ID and password. And once you go inside this, you need to create a new CI/CD pipeline. Okay, so this once you give CI/CD, it will automatically say what type of project it is, whether it is a freestyle project or Maven project or pipeline project. You can click the pipeline and the pipeline project will be automatically created by the Jenkins. Okay, so here I am once this project is given, I'm just giving the description. I need to give a description here. and I need to say this is going to be the project URL, like from where I am going to the source code, the GitHub project. Since it is a GitHub project, I am giving the GitHub ID here, like from where I need to take the source code and integrate it. So this is done. So once all these things are done, now we need to create a pipeline script. Okay. So pipeline script, as I said, okay. So pipeline script, as I said, it includes different stages like this. So you need to create first checkout. That is the first step stage I am having. So here I will be using all the URLs which needs to be fetched to get my source code from. And once that is checked out, the next stage is compile stage. So compile stage, it will be compiling the source code, and next it will be building it. So once it is done, a build which can be used for which can be deployed is ready based on my changes. Okay, then you come to the testing phase. So testing stage. In the testing stage, you can create n number of testings you want to use, like unit testing, load testing. All these testings can be included in the testing script, and you can create a script testing phase like this. Then the deployment stage. So to deploy it, I am using a Tomcat server to deploy it under this login. Then at last is the monitor stage. So whatever the stages which I have discussed in the earlier stages of my slides, I have created all the stages here as a pipeline script. So once this pipeline script is done, okay, you need to start the pipeline. You need to start the pipeline. So what it will do is it will fetch all your source code from the GitHub, compile it, make a build.var file. Then, as I said, in the testing stage, it will do all the testing in the Selenium tester, and using Tomcat server, it will deploy it to the real world application. Okay, so this is how all the stages will be dumped to you in the Jenkins plugin. Okay, it will say the first stage build is like checkout is successful, then compilation is successful, testing is successful. So each stage it will give you a this idea like what stage it is it, and if there is any problem in different stages, that will be given to you. Okay, finally it will automatically launch all your changes using the Tomcat server into the using the Tomcat server, and it will be finally deployed. Okay, so once it is deployed, the monitoring process will start in the Jenkins itself. There will be two monitoring stages. One is the dashboard stage, and another one is the pipeline view. Okay, the dashboard change will say it will give you like idea like how much time is taken for each of the stages, and the pipeline view will be saying whichever green indicates success, so whichever is successful and whichever is having an issue. So all these things can be monitored here. So at last, the website which I have created will be hosted within less number of time by the Jenkins pipeline itself into the real world application. So now if I want to do any changes in this particular website, I don't want to waste the time. I can continuously, I am having the source code in the GitHub. I can check out the code, and I can do some changes, and I can check in and start the pipeline process again. So it will be continuously recursively deploying the cases. So as you say, this is the 18th change I am doing. So all these things will be coming. So if I like that, every ID, every deployment will have one ID. So if there are 17 triggers which are happened earlier and 18 is a problem, I can remove the 18th one and go back to the 17th one itself. Okay. So yeah. Basically, until 1991, as I said, the linear approach was used, and the software development cycle used to be a long process. But now, with the concept of CI/CD, once someone is going to deploy at the same time, someone is developing the next version of the software. It's at the same time itself. So you are going to have a good, efficient, and less time consuming software upgrades uh, very at a very frequent intervals at a very efficient manner. So that is the major advantages of using this CI/CD pipelines. Okay, so yeah, so I'm almost at the end of my slides. uh, I can, I think this PPT will be available for everyone to download. If that is the case, then everyone can, I advise that everyone can use the source codes which I have given in the PPT and use the Jenkins tools and create a own pipeline on their own and try it out. Whatever I have given in the slides are already available using that links. You can use that link and you can continue to do a testing and create a pipeline on your own and have some hands-on experience on this. Okay, fine. Yeah, I am done with my slides. Thank you.
Thank you, sir. Thank you for enlightening and thought-provoking session. We are grateful for time and effort you took to share your expertise with us. Thank you, sir. Before we conclude, please feel free to ask any questions and clarify your doubts. Participants, let's have a Q&A session for 5 minutes.
Yeah, one of the chat I could see is how can you manage secret and sensitive data in CI/CD pipelines? Okay, so as I said, we are having a common source repository, right? In one of the slides, I have in this example, I have given a GitHub. So how you make the GitHub confidential and secure enough, that is how you can manage it. Say, for example, if I am making sure the GitHub password is, I am only having the GitHub password, and I am whatever the source code is having, no one can visible. Even if I am uploading it in the Jenkins, if someone is giving a wrong GitHub password, that will not be available. That cannot be seen from the outside world. So this is how you can manage how you can manage any secretive or sensitive data while creating the pipeline. So you need to make sure the source code management where you are creating that source code should be secure enough. You need to make, as I said, the GitHub and the Perforce are already having best security in place. The user ID and password for those repositories should be confidential, and if you are managing that, then the sensitive data will be security free. That is what I can assure you.
Now mic is open to all. Dear participants, if you have any questions.
Hello.
Yeah, tell me.
Sir, can you tell me what is the mechanism adopted to secure CI/CD pipeline?
What is the mechanism to
Adopt secure to make a secure CI/CD pipeline?
Yeah, that's what I said, right? Make a source code repository as secure as possible. Like use standard source code repositories like Git, Perforce, and make sure you are having a good credential case in those cases. So once your good GitHub, once your source code repository is secure, then that means your code is always secure and your pipeline is also secure. So anyone can create a pipeline out of the source code, but if the source code is not, if every time the source code management repository will be asking a password. And if the pipeline is not able to crack that password, then your source code is safe. So that means security, right? So that's what you need to make sure.
Thank you, sir.
Yeah, one of the comment I could see is CI/CD permits updations very often in the code. Yes, sir. There is a negative approach also to her. I think I got a name as vice principal. Okay, sir. There is a negative approach also, sir, for it, sir. Like many people are integrating, and many people are updating it very frequently. Is not a good approach. But there are some positives also, like how you manage your team. Say, for example, you are having a team of 10 members, and one member is like frequently like doing a one-line code change and integrating it, um, and that then he is starting the pipeline on his own. Then it is not a good practice. So it is like the coding practice also needs to come, and that is how that is the role of DevOps. Actually, um, uh, DevOps will be having a control over the integrate developers and also the operation teams. So the developers also should make sure they are not going to do updation very frequently without any unnecessary changes required. If there is a valid case, okay, there is a case like customer is facing a problem with some application in one of the page is having a bug that needs to be fixed. That is so that need not be waiting till the next upgrade of the software. That can be fixed immediately. So that is the pros, and there are also little bit cons. But using, say, effective use of the pipeline is another one big topic. How you can manage your team, or how you manage the developers, how you manage the operation, and how the DevOps should be behaving to make sure all these things will be all these things can be all these things can be carried out really fine and effectively. Hope I answered your question. Yeah, one of the free online, whatever I have shared in this PPT, all of them are available freely in the market. Even Jenkins is having a free version. If you just download Jenkins and follow these steps, whatever the steps I have given in the slides, that will be a good introduction to create your own start pipeline first. So that is my answer to Priya for free online resources. Okay. Just give me a minute. Test failures in CI/CD pipelines. Yeah, like if your test is failing, then it is not a good test, right? Like you need to make sure you have the correct testers. Say that is the concept of DevOps. That is the work of DevOps. Like you need to have all the testers to be correctly done. Then only say say so you from your question, Lavanya, I could understand is how you handle test failures. So once the test is failed, that means the build is not shipped to be not perfect to be shipped out. So you mark that build as a red flag build or something. So once the red flag build, you mark a build as red flag. That needs to be reverted by the, as I said, right? Every developer will be doing one change. That change will be created as a build. So that build is having a fixed issue in the testing, so that we mark that build as a red flag, and that build should be reverted back by the developer, and they need to fix that whatever the failures you see in the testing. So that is how it needs to be taken care of. I think any other questions I missed? Maybe I can give you a chat reply here because I'm running out of time also. If it is good for you, I can continue further. Response to Aishwarya Mano, yeah, that the question I have replied, responded to Vice Principal Sir. Yeah, if there is continuous deployment, everyone will be using it more often, changing it more often. You need to have a better DevOps procedure to make overcome this scenario. There is nothing called a minimum configuration system. A reply to San Pendima. Whatever the, as I said, Jenkins, whichever is available, it is like an free software is available. That usually works with all the OS and other versions. So you can download any of the free versions which is currently available, and you can start. I have not replied to Mr. Professor Rajul. I'm not sure where I have mentioned Terraform in my presentation. If you can briefly ask me what is that Terraform means, I can reply to that accordingly. Yeah, fine. I think that's it. Thank you all. Thank you for the session. It was very good to be interacting with the team like you, and it was a very good deep learning for me also.
Thank you, sir. Thank you for your informative session.
Thank you, Mr. Prabhakaran, sir.
Thank you. Yeah.
Participants, without any delay, I request Dr. N. Balaji sir introduce our next speaker, Mr. Ravi Kulkarni sir. Sir, please.
Yes. Good evening to all the participants. Good evening, Mr. Ravi Kulkarni, sir.
Yeah, good evening all. Good evening, sir.
Sir, yesterday taken the topic container orchestration with Kubernetes with the hands-on.
Yeah.
So today also sir will continue with our FTP presentation. So it's my pleasure to welcome you, sir.
Yep. Same here. Okay. Yesterday's session was also really good. Okay. So I believe that I'm gonna make the same today also. So with your permission, sir, I'll start my session.
Yes, sir. Yes, sir.
Yep.
You can.
Thank you. So let me share my screen over here. Let me see if I can do that. Okay, and a few more things if time permits. Okay, I've seen just I joined 5 minutes ago, uh, and people were asking a lot of questions with respect to the CI/CD and all. Okay, so if time permits, okay, I'll try to give some inputs with respect to that. How you can prepare with respect to the DevOps, how you can prepare with respect to the tools, technologies, from where you can find some open source tool or frameworks and all those things. Okay, so let's see if the time permits. Okay, so let's go. Let's start with today's session, that is Kubernetes with the Helm. Okay. So I believe we have got fair idea with respect to the Kubernetes. That okay, Kubernetes is an orchestration tool, and when we use that for deploying application, deploying the microservices which are there in the containers, so on and so forth. Okay, so just like that, okay, rather than just using kubectl, okay, they have developed a tool called Helm. Okay, so what is Helm? It's basically a package manager. Just like in the Linux, we have a simple package manager like RPM is there, yum is there, okay, apt get or apt in Ubuntu is there. Okay, in the same way, we have a Helm for the Kubernetes. Okay, as simple as that, a layman definition that we are going to understand. Now, what we are going to learn in today's session, again, we are going to start with the Helm introduction. We'll understand about a Helm architecture. We'll understand about the Helm charts, and then going ahead with that, we'll understand about how to install them. What are some common Helm commands which are being used? How to create Helm charts? How to understand the chart templates, Helm repositories, Helm releases, okay, values.yaml, Helm values dependencies, how you can install, upgrade, and uninstall the different chart, how you can do the rollback. Okay, all these things you are going to learn it. Okay, mostly it will be a theoretical session. I'll try to put some demos, okay, mostly about how you can deploy it using the Helm. But yeah, this will be more of a, walk you through the tools perspective with respect to the Helm. That what is the capability and capacity of the Helm, okay, in that way. So let's go ahead. So this is pretty much my introduction. I have already covered that in yesterday also. But quickly, I'm a GCP certified DevOps professional. Okay, I have my own company, SSK Training and Consulting, and I'm a freelancer working on the DevOps project and work as corporate trainer also with 14 plus year experience in IT. Okay, these are my expertise with CI/CD, GCP, AWS, container technologies, CI/CD, infrastructure as a code, so on and so forth. Okay, now to start with, what exactly this Helm is? Okay, let's understand. So I believe on diagrammatic representation. So I always do that. So let's understand that in a diagrammatic way. Okay. Now I have my OS over here. Okay. This is my operating system. Let's take that. This is a Linux OS. So Linux OS. And somewhere here, I'll put it that I have my Kubernetes deployed. Okay. This is my Kubernetes cluster. Just assume it. Okay. Let us do that. Okay, let me check it quickly. Yeah, I'm better now. Yeah, you can see on my face also and through my voice also. Thanks, Durga, for that inquiry. Okay, so coming back to this, Linux OS is there and Kubernetes cluster is there, right? So let's say that I want to install, let's say I want to install a JDK. Okay, install JDK on the Linux. Okay, assuming that it's a Red Hat Linux. Okay, I'm just giving the name also over here, assuming that it's a Red Hat Linux. So which command we can use it to install the JDK? Maybe something like this, right? We have yum install. We can use yum install JDK, or we can have, if we already we have RPM package, which is Red Hat Package Manager. Okay, so RPM is Red Hat Package Manager. So RPM, and then you can just go ahead with the, sorry, here you can just put something as Java 11, something like that. It will be okay. And here you can have hyphen IVH, and then you need to give a complete RPM hyphen 11 dot head list, something like that, dot RPM, like that, you can install it. Okay, this way or this way, right? So this is how you can install it. But have you understood like from where these things are coming and how these things are created? So there is something called as yum repository, which is kept somewhere here outside on the internet. Okay, this assume that this is a simple internet is there in the blue color. Okay, the sky is blue, so I am assuming internet is also blue. This is my fantasy. And somewhere here I have some remote repository. Let's assume that this remote repository is keeping some packages, right? So something is happening like from there when you give this command, okay, they are downloading the JDK and installing it over here, right? In the same way, if I want to do something in the Kubernetes cluster, okay, if I want to do something in the Kubernetes cluster, so what I need to do is I need to install one tool called Helm. Okay. So this tool is going to help me, okay, to deploy the packages on the Kubernetes. Now, which packages? Application packages, any application or anything. Okay. So Helm will help to deploy the application packages, okay, to the Kubernetes cluster. Okay. So this is a very high level or layman idea about the Helm. Do you got this? Any doubts in this? Are we good? Are we good on this? What is Helm? A simple package manager. Now we are going to learn with respect to that how we can use Helm, what is required to run the Helm, okay, and what are the different components of it, how you can create a charts, how you can create a templates, values.ml, deployment.ml, so on and so forth. Okay. So Helm, what is Helm? It's a Kubernetes package manager that simplifies the deployment and management of application in Kubernetes cluster. Helm enables reusability, versioned application called charts, making it easy to manage deployments consistently. Okay, that means you can create your charts. Okay, so there is something called as a resource called as charts. So once you prepare that chart, you can deploy that using the Helm. Okay, and inside the chart, we have written that which application needs to be deployed. Okay, so just like here we have a Java 11, we call it as package, right? Java 11 is our package here. Similarly, with the Helm, we have something like this. Okay, so what we do is we say Helm install, let's say app 1.0.1.0, okay, TGZ or something like that. So this app 1.0.app is called as chart. Okay, so basically it is the chart zip file. We will understand about a chart in a minute or so. Okay, but understand that as simple as that. So there are two things. First, a Helm as a tool. Second, a chart. Okay, which will be having the information for the application deployment or all the details with respect to the application. Okay. So key components of the Helm. The first is Helm client. Okay. Let me show you this. Again, the same thing. I'll put it over here. Helm client. So what is Helm client? It is the Helm. Okay. How you can install it? Okay. Yum install a Helm, something like that. Or you also have a repositories to do that. Okay. So if you give prompt Helm, you will be able to see all the details with respect to that Helm. Okay. So basically a Kubernetes manager, and these are the common actions with respect to Helm. Helm search, pull, install, and list. Okay. Thumb rule. Helm as a client, and second is charts. So what you are going to do is you are going to prepare the chart, and what Helm is going to do, Helm is going to deploy that chart. Okay. So first Helm client, Kubernetes cluster, Helm repositories. Okay, where you store your Helm charts. Okay, where you store your Helm charts. Okay, then Helm charts, as in these are the predefined reusable Kubernetes resource definitions that contains all the necessary information of the configuration file with respect to the application, right? What is the version of application to be deployed? What are the secrets through which we should take the Docker images? Or what is the label? What is the selector? Everything is mentioned in the Helm charts. Okay, everything is mentioned. Okay, we will see that. And now this is Helm v2 Tailor. Okay, the server-side components. Now it is removed in Helm 3 version, but I just wanted to tell you with respect to the Helm 2 version if you are using, okay, for the simplicity and security reasons, right? Helm, if you want to go to learn about Helm, pretty simple. You go to helm.sh, that is the official site, okay, and you go to the docs. Just click on the docs, and here on the docs, pretty much everything is mentioned, right? So if you go to the introduction, you'll see that quick start guide, how to install the Helm and how to use it. Okay, so this is install how to install the Helm, so on and so forth, right? And how to get initiated with it, example.chart and all those things, right? If you want to go ahead with the deep dives, okay. So here are where is that how to, okay, how to guide is there. So how to means particularly the chart development tricks and tips are there, so on and so forth. If you want to understand about Helm commands, you can go ahead, and these are the Helm commands. So there are lots and lots of Helm commands which you can have it, and every command, let's say Helm package is there. Okay, the Helm package command, you click on that and you'll be able to see all the synopsis, how to use it, and maybe with some examples, you'll be able to see it. Okay. Uh, Best practices also, all these things are given over here, and then there are topics. What is chart? Basically, if you want to understand what is chart, so a very good website. If you explore it, you'll be able to see all the required things. You start with as simple as that. Go to helm.sh, okay, and go to docs, and then go start with the introduction. So in the introduction, start with the quick start guide or installing the Helm, using the Helm, and then cheat sheet. Cheat sheet also one of the very powerful resource in terms of understanding and in terms of making the progress, fast progress in the Helm. Okay, you want to learn it fast, you want to use it all the required or the basic commands, it is really good. Okay, let me put that over here, the docs page, so that you will have references with respect to this. Helm. Is that? Yeah. So let me just share it with you. So these are the talks. Okay, pretty much everything, whatever you want. Selvi, Tamil Selvi. Yeah, thank you. Yeah, yeah, sometimes it happens. Okay, again coming to our conversation, starting with the right. So what is Helm? Is it basically it interacts with the Kubernetes API to deploy the charts, and Helm releases are the instances of the chart deployed in the cluster. Now there are some components or the key things which we have to understand. Okay, first is chart.yaml. What is something happened? I think. One minute. Right? Yeah. So chart.yaml. Okay. So let me give some example to you. Now, if you have GitHub, okay, pretty much what you can do is you go ahead, open it, and you simply search for chart.yaml. Okay, you'll be able to see lots and lots of repositories. Let's say that this is open anything. Okay, and you will be able to see chart.yaml over here. Okay, maybe this I can open it. Right, this is pretty much one. Or let me just go ahead with as simple as that sample chart dot YAML GitHub. Let me do the Google search over here, example dot chart. Okay, let me just open it for you. Right, pretty simple. Okay, so this is what my chart.yaml is. Okay, remote means I'm going to mention the remote as origin. Origin means it is this repository. Okay, this is mostly the word related to GitHub repositories and all. And chart directories, it is defining from where I should read the chart. It is charts. Yeah, okay. So now these charts, if I go to the examples, I should be able to see the charts folder. So here I have a charts folder. And if I open the charts folder, now this is my chart.yaml. Okay. So I have chart.yaml over here. If I open it, I'll be able to see name of the application, API version of the Kubernetes on which using which it will be deployed, name of that, bit of description with respect to that, type, whether it's application, load balancer, what exactly it is, what is the version of the application, what is the version of the chart, and sorry, what is the version of application. Okay, so I'm going to install 1.16.0 app version of the name Hello World. Of the name Hello World. So this is how my chart.yaml is. So it provides a basic information about your application to be deployed. Okay. Now going ahead with the next values.ml. Now values.ml. Now what is values.ml? So it will have all the required values which are required by the chart. Let's say I want to define, okay, I want to define which Nginx version I should deploy. Okay. Now if I want to search for Nginx images, okay, Docker images, and if I go to the Nginx official image over here, so there are number of images over here, right? So I have stable Perl, and so on and so forth. Okay, 1.2, and so on and so forth. Okay, but I am looking out for a particular version. I am looking out for a particular version. So I need to define the tag of that image. Okay. So here I'm going to mention the tag of the image. But let's say uh, in every deployment of Hello World, okay, every deployment of the Hello World, I want to change my tag. Let's say for one application, I want to install Nginx 1.14.0. For one application, I want to install 1.15.0. For one application, I want to install 1.16.0. So how I'm going to manage that? That will be done using the values.yaml. Okay. So I'll have the same chart, but I will have three values.yaml where I'm going to define, let's say one for development, one for production, one for testing. Okay, so accordingly, I'll have my values.yaml. So what is values.yaml? So here we define the values, okay, for a particular variable, which we are going to define that variable in the templates. Okay, so let's understand that. So first we have chart.yaml where we have all the details that, okay, name of the application, version of the application to be deployed. Second, we have values.yaml, where we have a default configuration values or we have a configuration values with respect to the chart. Okay. Third, we have a templates. Now, what is template? So basically, these are nothing but a templates of the deployment services, ingress, so on and so forth. So all the Kubernetes resource definitions are defined in the template. Okay, in the template format. Now, what does that mean? In the template format means templates are created with the variables. Let's go ahead and see that. So deployment is there. So here we have include hello world dot full name. Okay, hello world dot full name. Now if I go to my chart, here we have values.yaml, right? So basically we have full name override is nothing. Okay, so it is going to take what in this, in the template, it is going to take a default name because we have not defined anything over here. Okay, because we have defined the chart name as hello world, so it is going to take the full name over there, but we have not defined anything, so it is going to take the same name as it is. Okay, the replicas from values dot replica count. Values means values dot yaml, and then there is a value defined for the replica count. So if I go over here and if I go down, if I show you values dot yaml over here, okay, I have a replica count should be here somewhere. Yeah, so here I have replica count equal to 1, right? So my values dot replica count will be 1 over here. So it will automatically get replaced. Okay, so that is what a template is all about. So a template is nothing but a chart or a YAML file, a deployment YAML file, a service YAML file, any YAML file, okay, with the variables, and those variables will be replaced with the values using values.yaml. Are we good? So what is template? What is chart? What is values.yaml? Three things. So that I can move ahead further. Are we good? Any doubts? Any questions till this point? Yes, I know you are tired. You have a lot of things. I mean, you will have dinner and all those things are there. For sure, I understand that. Okay. But yeah, sometimes you have to, go beyond that thing. But yes, I see that there are few uh, thumbs up. So considering that as yes, I'm going further with respect to two more things. Okay, so sample values.yaml. Yeah, so charts.yaml, values.yaml, templates, and then charts. Charts means inside the chart you will have some chart dependencies and all. So this is the chart, and then in the chart I can have multiple charts. So first chart is hello.world. The hello.world will have its own chart.yaml, values.yaml, and templates. Okay, if you go to another charts, you will have your another values.yaml. Okay. Sample values.yaml. As simple as that, you are defining the values. Replica count is to image. I need to take repositories, nginx, tag is latest. So all those variables and its their values, you are defining it in the values.yaml. Okay. Installing the help. So how you can install it? Pretty simple. Mac OS. This is the command, right? Using the curl command, go ahead and install it with the bash. With on the Windows, you can do it using the Chocolatey. So Chocolatey is again a new package manager provided by Windows PowerShell. So you can use go ahead and install Choco. Choco install Kubernetes help. Okay, as simple as that, you can do it. Okay, maybe on the Windows I can show you if I don't have a helm over here, and maybe PowerShell. Sorry, not much fan of Windows, but yes, this is install Kubernetes helm. Okay, Choco is not there. Okay, so I need to install the Choco and all. Okay, probably yeah, I need to check that method. But yeah, so Choco, you have to install first the Choco and then you have to install the Kubernetes helm. Okay, and you can check in the helm version. So pretty simple. On the Mac or Linux, it is as simple as that you download it and you install it. Okay. Now these are some common commands with respect to the Helm. Okay. Helm install the release name and the chart path. Okay. Now we have to understand few things before going ahead. Let's do some hands-on over here. Okay, or maybe I'll show you something which I have over here. So just allow me 1 minute, please. Just allow me one. Okay, so let's. Yeah, Shubha, you have any question? Shubha, you have any questions? Okay, maybe you can put the questions in the chat. Okay, let's go ahead and let's see that. Right. So I have already prepared this, okay, using, of course, using the chat GPT. Okay. Pretty much easy to, create your document using the chat GPT. So this is what a step-by-step guide, which we are going to follow it. Okay. So let's see that how we can create the chart. First of all, we'll go ahead and we'll give this command helm to create the chart. Okay. So what it is going to do is it is going to create a simple framework of the chart over here. Right. So let me clear it out. Paste one. Right. So helm create my chart. Okay, as simple as that. So what is it is going to create it? It is going to create a simple framework for me with the name my chart. Okay, same you can do it for hello world also. Okay, just it is the name given to the chart creation. Let's say that hello world. If I'm creating it with the hello world, okay, typical, you will be able to see hello world is also there, right? But overall, the structure remains the same. So I've deleted that. So my chart, if I go ahead and if I show you, okay, inside my chart, you'll be able to see I have chart.yml, as simple as that, values.yml, okay, and the templates and the templates. And if you need some dependency charts, you can define it over here. Okay. So I'm not, as of now, I'm not going to define that. So I've created my chart basic things. Okay. So let me go ahead and let me add few things to my values.yml. Okay. So my values.yml replica count. See, this is the replica count 2. I'm going to put 3, and then the repository is nginx and tag is 1.14.2. So let me go to my values.yml over here. It's automatically created for me. Replica count is 1, so I'm just going to put that as 3. Okay, and let's say tag, I'm going to put it as 1.14. What is that? 2. Okay. So pretty simple. Any doubts in this? and I'm going to save it. So ls.m, I'm done. Now I'm going to go ahead with the templates. So as I told you yesterday, those who were there in the session, okay, they know there are two things we have to do it while working with the Kubernetes. So first we have deployment.yaml, right? So let me just cat it. Okay. So now this deployment.yaml is completely auto-generated. So I'm not looking out for this. Okay. So let me write my own deployment.yaml over here. So let me just rename it as of now. Okay. So I'm just going to move this deployment.yaml and create my own. So if I go ahead and if I put deployment.yaml and then I'm going to add these things and that deployment.yaml. Sorry, what happened? Something happened. Oh, 1 minute. Let it log in. So do I have that? Okay. Again, I'm going to create it. Okay, the same thing and modify that. My charts. Okay, so my chart is created. So I'm going inside my charts. Okay, and I see values.yaml. So I'm going to modify the values over there. The first one is replica count, which I'm going to make it 3. And then 1.14.2, right? The tag I have updated it. Then let me go to the templates. So now as I told you, I'm going to modify my template. Okay, so let me delete this deployment.yaml. As simple as that. Okay, without wasting much time. So I'll create my own deployment.yaml, which I'm going to copy it from here. Okay, paste it as a plain text. So I'll explain you. API version is the version using which we are going to interact with Kubernetes. Kind is deployment. That means we are going to deploy the Kubernetes resource, which is deployment. I'm going to define the release.name is there. So whatever the name, this release name is there. So the same thing, we are going to give it over here. Values.replica.count will be coming from values.yaml. Again, release.name, we are going to define our releases over here, right? Values.image.repository is again going to come from values.yaml. Values.image.tag is again going to come from the values.yaml, right? So I'm just going to define this template, save it, and then the next one I'm going to delete service.yaml, the default one, and will create my own service.yaml. Okay, so this is my service.yaml, pretty much the same. If I have it, paste it. So now I'm ready, right? So I created my deployment.yaml. I created my deployment.yaml. I created my service.yaml, and I updated my values.yaml. I kept deployment.yaml and service.yaml into the templates folder, and now I have a ready chart, right? So next thing I'm going to do is I'm going to create the package of it. Okay, so now my chart is ready. Okay, my chart is ready. So I'm going to package that chart. Where I'm going to package it? On the chart level. Okay, on the chart level. Let me just show it to you. Where you need to go? On the my chart. Okay, where you will be able to see these files. Okay, at this level, you have to package it. So Helm package dot means the current directory. What Helm is going to package? The current directory. That means dot. So my package successfully packaged the chart and my chart is created. So my chart name is my chart dot 0.1.0 tg set. Okay, this chart is created. Till this point, do you have any question? Now I'm ready with my package, right? Now I'm going to install my package. What I'm going to do is I'm going to install my package. So let's go ahead and let's install the package on the Kubernetes. Okay, non-absolute repo path to chart, got it. My chart is inside. Ah, 1 minute. So Herman install my release. Install my release. Okay, so it is not loaded. Perfectly fine. Okay, can anyone tell me that what is the why this error has came or what is the issue? Anyone quickly? Let me just show this to you. If you have any version not supported or no, anything else you can think about it. You see, it is my charts hyphen 1.0.0. And here I am trying to install my chart only. Okay. So there is a name. There's a difference in the name, right? So you have to make sure that you are just giving the right name at the time of release. Okay. So what exactly I'm doing now? I'm trying to install it with the name my release. Okay. So this chart will be deployed with the release name my release. Okay. So let me install it now. So here you see my chart has been deployed. So my namespace is default, status is deployed, revision is 1. Okay. And the things are going good. Perfectly fine, right? So if I go ahead and if I check my Kubernetes get pods, I should be able to see 3 pods are running for my Nginx. Yes, my release, 3 pods are running perfectly fine. Any doubts in this? Right? And if I go ahead and if I say kubectl describe pod, is it okay? I should be able to see that particular version, that is 1.14.2, that should be deployed. If I go ahead and if I see yes, so for me in my pod, you see 1.14.2 has been deployed. Okay, cool. So I'm happy with that. Let's do one more thing. Let's now modify the values to some other value, which is, let's say, I'm going to modify to 1.16 and let me save it. And again, I'm going to say Helm package my chart. Okay, so my chart is saved. Okay, if I go ahead and if I again try to, install my release, what will happen? Let's say it is saying Helm install my release is still in use. That means you cannot modify it unless you have to uninstall it, unless you uninstall it. But I need to do that, right? How I can do that? So let's understand those commands first. But till this point, I believe you are okay, right? How to use the helm? First, create your values.ml. Second, in the templates folder, create your all the required templates, deployment, service, load balancer, whatsoever you wanted. Then you package it with the Helm package and then you install it. Okay. With some name of the release, right? That is what we have done till now. Let's move ahead and let's go ahead with the next thing, which is Helm install. We have seen that deploying the chart to the Kubernetes cluster, and we have seen that, okay, our things are running. Helm upgrade. Okay. So yeah, if you want to upgrade the existing release, okay, and the chart path, so I can use upgrade. So can I use that? Let us try to do that. Okay, let me do that. Okay, so you see that the revision 2 and I'm able to upgrade my release. Okay, now let me see my Nginx version with respect to my pods is updated to 1.16. So Kubernetes kubectl get pods. So I have my pod and let me see kubectl describe pod. Yes, it is a plain text and here it is. Go ahead and you see Nginx 1.16 is updated. You got it now, how I upgraded it. Okay. And if you remember, yesterday we have discussed about rolling updates, right? So there is no downtime over here. There is no downtime over here. So this is how I'm going to upgrade it. So I'll install him upgrade. Okay. If you want to roll back the release, you can also roll back in the same way. Okay. Without any issues. Okay. You can just put it the release name and you can put it the revision. So if I say like clear, and if I say helm, roll back. Okay. Rollback is successful. Okay. As simple as that, my rollback is there. And if I now go ahead with get the pods, right? And if I say describe my pod again, what will happen? Okay. Again, my Nginx is back. My application is back to 1.14. Got it. So this is what my rollback is. So I got Helm installed. I got upgrade also. I got rollback also. And uninstall, let's say that you really don't want it. You go ahead and you with the Helm, you uninstall it. Uninstall my release. Done. So if you go ahead and check the pods now, you won't be able to see any pods. Okay. So my deployment is done. So these are pretty much daily commands which you are going to use with the Helm chart. Got it? Any doubts in this? Are we good? Okay. Next thing. Okay. How to create the chart? We have just now we have seen that, but we will go through it. Okay. Quickly about in few words. Um, oh, it is at 24. No? Okay. In 5-10 minutes, I'll be again open to some questions. Right. Okay. You can create a chart as simple as Helm create my chart or Helm create name of your chart. You can just put it. Okay, so what Helm will do? It will generate essential files that is chart.yaml, values.yaml, and templates. You can modify values.yaml as per your configuration, as per your settings, and then you can keep it as per your environments. Okay, so let's say there are dev environment is there, there is a release or production environment is there, there's a test environment is there. So you can have three values.yamls. Okay, keeping the chart same, the templates are same, but three values.yaml, one for dev, one for test, one for production, right? Chart rendering. Okay. Um, how many of you understand what exactly rendering is? Quickly, what is rendering? Okay, so path is not correct. Am I right? Yeah, path is not that. It's correct. Path is not correct. Yeah. So after rollback, if I want to get it again, what I have to do? You have to again install it. Okay. So as simple as that, you can just use the revision also to install it. You again install it, or if you have any once you uninstall it, you also install it in the rollback also. Generally, rollback is done when you have what do you say production failures, or maybe the you have done the installation that is not working fine. So you quickly do the rollback. So in that case, you go ahead and you deploy the new version or the modified version of your chart. Yeah. Yeah, correct. Okay. So Helm templates render the Kubernetes YAML file based on values provided in values.yaml. So basically, if I say rendering means using the templates, it uh, creates a Kubernetes YAML file. So basic, if you go ahead with the basics of Kubernetes, there is something called as YAML file, okay, where you define your all the things. Whatever, maybe it's a deployment, it's a service, it's a load balancer, Nginx, egress, as per your choice. But basically, it is a YAML file which is provided to the Kubernetes, right? So what Helm templates render is Kubernetes YAML file based on values provided in the values.yaml. Okay. So command, you can use it as simple as that, Helm template my chart. Okay, so what it will do, it will generate Kubernetes resource definition without applying them to the cluster. What does that mean is, if you want to test your charts, you can use chart template rendering. There are other ways also. So it is not only this is the way, but this is one of the old way of working. Okay. This is called as chart template rendering. Okay. Helm repositories. Now, this is a very good concept with respect to the repositories, with respect to the Helm. Okay. So now you think about it. I've created this chart. Okay. I've created this chart. And I really don't want that every time I'm going to just create this chart and what not. Okay. But I have this my chart.yaml charts template and values.yaml. How I'm going to work on this? Okay, I need to have some kind of repository where I can keep this chart.yaml, or where I can keep this all these things. So either first thing is you put it in the GitHub, and second thing is you add it to the repository. Okay, you add it to the repository. Okay, so if I say Helm repo list, sorry, my bad. Clear it out. Helm repo list. If I put it, so I don't have any repositories to show. Let's go ahead and let's add something. Helm repo add stable. Okay. Let's do that only. What is going to happen? So it is going to ask me the URL. Okay. Let me give some URL. Okay. Pretty much URL. Simple URL. Let's say www.training.com/helm repo, something like that. Okay, I'm just giving it. Okay, so it is going to give the error. Okay, not a valid chart repository. Can you tell me why? Any thoughts behind it? Any thoughts? Why I'm saying that adding, I'm trying to add to repository, but it is not taking that. Okay. Remember that just like we have Docker repositories, right? We have Docker Hub, right? Similar to that. Okay. We have Helm repositories also. We have Helm repositories also. Okay. You have Helm repositories also. So you can add the Helm repository, you can list the Helm repositories, and these are again the standard remote repositories which you can, you know, add it. So let's say that this is the one. So you can add. So for this, you need to have a standard URL. That means you need to have a Helm repository. You can create it Helm repo on JFrog. So JFrog is the website where you can just have your Helm repository. Okay, you can start it over free, or you have Nexus also, Helm repository, where you can just create a repository over here. Okay, so now type Nexus. We can just create Helm repositories over here, right? And then take that URL. Okay, hosting your Helm repositories. So you can host it over here. Take that URL, host port name repository URL, and then go ahead and mention it over here. Okay, so it is as simple as that. Your GitHub repository is there, right? So your GitHub repository is there. So what you do is, well, you create a GitHub repository, right? And then you go ahead and you give HTTP URL of that. Correct? In the same way, you have to create the Helm repositories also. Okay, and then give that HTTP URL to it. So that is the concept of Helm repositories. Okay, so this is the typical repository which you can add it to your repo. Okay, just like you do it with respect to your what do you say, Git and GitHub. In the same way, we have over here Helm repositories. Okay, similar to that, just like you do Git pull push or Git update. In the same way, we have Helm repo update, and then you can also Helm repo list. These are the commands with respect to the Helm repositories. So what are the Helm repositories? These are the repositories which are created for uh, keeping your Helm charts. Okay. Moving ahead with the next. It is 8:30. Okay. Let me give another 2 to 3 minutes for you to have some question answer sessions. If you have any questions, do let me know. Another 2 minutes, or we will move ahead with the next. Any questions with respect to the Helm till this point? Are we good? Okay. So let me do one thing. Okay, let me stop presenting for a minute, and let me put the questions in the chat. Okay, let me see that how many of you can answer those questions. Let's do that in 2 minutes. Okay. So let's go ahead and let's see. So pretty simple question which is coming to you is this. What is Helm in Kubernetes? Container runtime package manager, a network plugin, it's a B, right? Okay, which command is used to install the Helm chart? Okay, yeah, okay. So let's go ahead. Let me put it. Which command is used to install the Helm chart? Helm get, Helm fetch, Helm install, Helm deploy. Install, correct. Right. Next question. What is the purpose of values.yaml? What is the purpose of values.yaml? Default configuration. Yes, C. Correct. What is the command to update the existing Helm release with the new configuration? What is the command used to update an existing Helm release with the new configuration? Helm patch, upgrade, apply, update. So those who have given answer as A, that is the correct answer. It is upgrade. Okay. The answer is Helm upgrade. Okay. Going ahead with the next. How can you list? How can you list all the installed Helm releases in your cluster? Helm get list show release. Yes, it is. A is the answer. Okay, Helm list. Okay, moving ahead with the next. So I believe that you are yes. It is open. Yeah. Okay. I believe you are following them. Okay. So I do test it using by putting the questions. Okay. Let me share my screen then again, and let's start with the next slides. Okay. So far, any questions apart from this? Any questions? Anyone? Again, I'm asking. Okay, no problem. Moving ahead with the next. Let me hide it. Let me start with my presentation. Okay, my camera was not on. Really sorry for that. Let me put it. Okay, so we understood about repositories. That is where we store our charts. Okay. Now Helm releases. So what is this Helm releases? So release is basically a deployed instance of the Helm chart. Okay. What we have seen here now is that, sorry, where is this? Right. So we have our my chart.yaml was there. Right. So let me do ls over here. Okay. Let me do Helm package. Right. My package is done. So let me try to release it. So Helm install my release and then my charts hyphen 1.0.1.tgz. Okay. So here I have my release. So my release is basically name of the deployment. Okay. So what I've done is I've done the deployment for my application. So my release is the name. So this is called as Helm releases. Release is basically a deployed instance of the Helm chart. That means a name given to the release. Okay. And you want to see the active releases, you can go ahead and you can see Helm list. If you list it, you will be able to see that, okay, my release is there. Okay. Namespace is default. For the default namespace, it is there. What is the revision? The revision number 1 is there. Updated. That means installed on this. Okay. It is deployed status is there, and then this is the chart 1.0.0 and app version is 1.16.0. Like this, all the details you will be able to see it over here. Okay. Helm status release name. Okay. Now, if you want to check the status, you can just simply go ahead and you can just put it Helm status and my release. Right. This is how, as simple as that. You can just check it and you'll be able to see that this is the status of my release. Okay. Now this is the get the application URL bar running these commands and so on and so forth. You can just try it out as per your choice. Again, these are something which are given for you. Okay. Just for our information, it is given. You want to go ahead with that. So this is what a Helm release is. It is nothing but it is going to give your information of the deployed application. Okay. Helm values. Okay. Modifying the values with the values.yaml. So basically, we have already discussed about it, but quickly again we will see. So if you have a custom configurations, let's say that you have a dev environment, you have a test environment, you have production environment, and then under that you have to deploy a single chart. So what you are going to do is you are going to create a simple just chart.yaml as it is. Okay, this chart.yaml, where is that? Oh my god. Yes, so this chart.yaml you are going to put it as it is. Okay, but values.yaml you are going to give it. And how you are going to do that? Okay, pretty simple. You add this to GitHub. Okay, and then sorry, let me initialize it. So as simple as that. Okay, go ahead. You initialize the Git repository over here. Do git add over here. Okay, so and then do git commit -m. Let's say this is for Dave. I'm just putting it. Sorry. This is for Dave. I'm putting it. Right now I have. Let me just try to commit it again. Huh? Okay, my name and all those things. But I believe, okay, I don't have much time, so I'm just going to clarify it. Okay. And then what you're going to do is you are going to check out some branch, let's say develop from this, and then you are going to check out some branch, let's say test. Okay. And then you will have Git branches. So Git branch hyphen a. Why Git? Not sure why. I'm really not sure why it is not working. It should work. Git branch hyphen a or Git branches should also work. Anyways, but then three branches you will have it: dev branch, test branch, and production branch. And accordingly, you have to modify values.yaml in that. Okay. So that is what you will be able to get it. Okay. There is that. Yeah. And then you go ahead and you deploy it. Helm install my release, my chart, set replica count equal to 2. Okay. Now here, uh, you can also do this thing is on the fly, you can change the replica count, or on the fly, you can change the values in the values.yaml. On the fly, let's say that I want to change the tag. I can just set tag equal to 1.16.0. Okay, replica count equal to 5 over here. As you can see here, my values.yaml has replica count equal to 3, but I am setting it at the time of Helm install, I am setting it to 5. So by default, it is going to take 3, but if you are defining it over here while installing it, you'll be able to get the replica count equal to 5. Okay. This is what Helm values is all about. Okay. Dependencies. Okay. So we have seen now, just now we have seen a plain chart.yaml. But let's say that you have any dependencies with respect to the charts, or you have any dependencies with respect to your application. So you can define these dependencies, okay, in the chart.yaml. So you can just define it like dependencies colon name of the chart, version of the chart, and repository URL of that chart. Okay, from where you need to take this chart. Okay, pretty simple. Everything you have to define in the chart.yaml, these dependencies. And then you can fetch those dependencies using Helm dependency update my chart. Okay, as simple as that. So when you say Helm dependencies update my chart, all those the dependencies which are defined in the chart.yaml will be downloaded. Okay, and then your chart will be when you package with the Helm chart dot, yeah, your dependency will get packaged into that. Okay, getting it? Any doubts in Helm dependencies? Are we good? Okay, considering further thing, right? Helm install upgrade we have seen now. Okay, we already seen this. But quickly again, I'm going to cover it. Helm install my release, my chart. So Helm install name of the release. You have to give it Hello World, Eagle, ABC, XYZ as per your choice, and you can have your chart definition over there. Right, my chart is there. My chart means if you don't package it, you give it simply with the my chart. If you have packaged it, you give the packaged one. Okay, either a zip format or a folder format, both will do. Okay, there is no issue with that. Helm upgrade my release, my chart. If you want to upgrade it, if you have modified anything in the values.yaml or anything with respect to the templates, you can just go ahead and you can upgrade your release. If you want to go ahead with the uninstall, you can simply put uninstall my release. So here you are not going to give any chart details. Okay, because already you have installed that release and you are just going to uninstall that release. So Helm already know that what needs to be done. Okay. Rollback command, we have already seen this, right? Helm rollback my release version 2. Okay, so as simple as that, we have seen this revisions, right? Over here, we have seen the revisions. So Helm list. Okay, here we have seen the revision 1. So revision 1, we can't roll back. So if it is the revision 2, 3, 4, 5, accordingly, once we have that, we can roll back into the previous releases based on your choice. So if you are on the revision 5, you can roll back to 3, 2, as per your choice, right? And Helm history, my release. You can just go ahead with that. Helm history, my release. Pretty simple. You'll be able to see that, okay, this is the history. If you go ahead and if you want to upgrade it, you can also get the history upgraded history over here. Okay, pretty simple, nothing else. Okay, secret management. So if you want to encrypt it, secret operations. Okay, so this is SOPs. SOPS is the command -e values.yaml, and then send it to values.enc.yaml. So what it will do is going to encrypt the sensitive values. Not sensitive, but it is going to encrypt the complete values.yaml. Okay, and if you want to decrypt it, you can go ahead with the Helm secrets decrypt values enc.well. Okay, these are again the pretty simple commands. Okay, you have to install the secret plugin is there. Okay, so secrets plugin you need to install it to the Helm, and then you can use this command, and then to decrypt you can use this command. Pretty simple, nothing else. I mean, nothing new in that. Okay. Helm templates and customizations. Basically, this is some advanced topic with respect to the template. So the templates, the basic templates are pretty simple. That okay, you have a variable like values.replica count. Okay, that's it, and then it is going to take that values.replica count and put it over there. Otherwise, you can have something called as if-else loop also, right? So if values.replica set is defined, then put replica count equal to that values.replica count. Else, if okay, if else, go ahead with the replica count equal to 1. That means what we are doing here is we are going to create if-else loop in the template itself. In the template itself, right? So this is also one way to work. Okay, rather than having a simple one replica count. Okay, where we can use it? We can use it, for example, there are two environments, and or if you want to have some default replica counts to be defined, okay, and you don't want Helm to fail the release. Sorry. Okay, managing the multiple charts. I think this is something with respect to the last topic. We have it with the Helm. Okay, and then we'll have best practices. That we will take it. Okay, don't worry about it. So Helm file, basically it is release chart and then which values.yaml it is going to deploy it. You can have that Helm file. So all these things you can define it into Helm file.yaml, which is nothing, which is not similar to your Helm. Okay, so Helm is just a command. Okay, just like you see Helm over here, you see Helm over here. Okay, where you have defined the files, but there is something like you have a Jenkins file. Similar to that, you have a Helm file.yaml also. And what you can do is you can just install a plugin and you can run Helm file apply. Okay, where you are going to define values.yaml, charts.this, and all those things, right? So this is again advanced Helm related configurations. So first we created a simple chart, then we modified values.yaml, then we added a loops to values.yaml, and then now what we are doing is we really don't want these things. We just created a Helm file. We are defining our name of the release. We are defining the chart. We are defining the values.yaml, and then we are using a Helm file apply to run the Helm releases. Okay. Best practices with respect to that, you need to have a role-based access. Okay, that is we call it as RBAC. Okay, pretty much simple. Okay, so role-based access means there is something called as authentication and authorization. So when I'm talking about role-based access, I'm talking about authorization, right? So pretty simple example I'll give you, right? So we all are authentic Indians, right? We all are authentic Indians. That means uh, we say that our nationality is Indian, but do we have the authority? Okay, just like we have our politicians or judge or bureaucrats. Okay, they can pass some orders, right? How the rules and regulations are. Okay, as a civilian, okay, do we have that kind of authorizations? No. So in the same way, when anybody can log into the software, okay, anybody can log into the software. That is where we use authentication. When what that person can do inside of the software once you are logged in, that is called as authorization. Whether he becomes an admin, whether she becomes an user or tester or developer, again that is called as role they are going to play. So authentication and authorization. So RBAC is very important when you go ahead with the help. So you define a proper role-based access control. Chart source auditing. Okay, now chart source auditing means now there are lots and lots of charts which are already present in the GitHub. Okay, so you need to make sure that you are sourcing the right charts. Okay. Maybe this PPT you can just Dean sir and ma'am can share it. Okay. So I'm not going much into deep into the Helm-based security practices, but these are the two things. You can do it and you can go through it. Okay. Debugging techniques. Basically, you can just have dry run simulation using the command --- dry run. If you want to debug the charts, you can go ahead and you can just put debug over there. So it is going to post all the verbose mode. And then you have Kubernetes logs also through which you can debug your deployments. Okay, most of common issues are charts error and configuration issues. These are again pretty simple. Okay, testing how we can validate the Helm charts. So you have a linting of the chart. That means basically your YAML configuration, how the YAML is based. Okay, so you can have Helm lint my chart like this, and it is going to check the syntactical errors with respect to your chart. Unit testing of your chart can be also be done or using the Helm unit test. You can define that under the test folder. You can create a test folder. You write the unit test. You have to write it. Okay, this is not something like Helm is going to do. You have to do it, and then you can use Helm unit test my chart test. Okay, and Helm test is also there to test your release. Okay, if you already have that any kind of test which are written for your application. Okay. With respect to the production, yes, environment specific values.yaml, as I already told you, right? CI/CD integration with the Helm. So you need to have such kind of CI/CD integration, particularly with respect to your GitOps model. You should always have it with respect to the Helm. And the security practices, we already discussed, RBAC and auditing of your charts. Right. So that is pretty much I have with respect to the Helm as an on the Kubernetes. Okay. If you have any questions, do let me know. Right. So I'm now open to the questions. If you have any questions, do let me know. Auditing tool, to be very frank, okay, we have not, audited it, but generally what we do is we generally check it from where we are sourcing it. Okay, for example, like let's say I'm using some public Helm repository. Okay, in that case, what we will do is we'll see that whether it is properly encrypted, whether I'm using the HTTP URL or not. In that case, Prometheus is mostly, I would say, a monitoring tool. Okay, again, there are different plugins to it. Okay, and maybe it is possible that you can audit it. Okay, but as a part of audit, what exactly you are going to do is, okay, you have any kind of vulnerabilities are there or not. Okay, that basically you cannot do it with the Prometheus. Again, you have to use some plugins, maybe SonarQube or something like that will be helpful. Okay.
Dear participants, now mic is open to all. Kindly ask your doubts and questions.
I know it is a bit late, and but still, if you have any questions, you can pass it on to me, or you can share it with the sir or ma'am. Okay, and probably they can share it with me, and I'll be able to answer that.
Before we wrap up, does anyone have any questions or doubts? Kindly clarify with sir.
Okay, there's a question from Ishwarya Mano. Okay, what type of authentication will you provide while validation? What type of authentication? So there are different types of authentication. You can have a username, password. You can have a token-based authentication. Let's say API token is there. Okay, so these kind of authentication you can just pass it on. You see that if whether your Helm chart is accepting that or not, or you get it validated. Okay, so accordingly you can just do the authentications also. Got it? Yeah. Smart contracts, as in I didn't got that. Smart contract means? See, blockchain as in see, I'll put it in this way is This is mostly an application based. Okay, so this is a deployment tool. Okay, similar to like you have Ansible is there, or you have a Terraform is there. Okay, so the purpose of the helm is to do the deployment in the Kubernetes and manage the deployment in the Kubernetes, right? So if blockchain application is there, you can just packet it into the containers, and then you can use helm to deploy it on the Kubernetes. You can process it. There are different types of controllers also in the Kubernetes. Okay, accordingly, you can just use it.
Okay. Thank you, sir. Thank you for your
Yep.
informative and engaging session. And we appreciate the time to share your knowledge with us, sir. Thank you.
Yep, yep. Thank you all for staying so long. Okay, till 9 o'clock. And I really understand that you are hungry. So maybe I think I was able to fulfill a bit of your curiosity with respect to the helm. And yeah, thank you, Dean sir and ma'am. Okay, for giving this opportunity. Okay, if you again, I'm putting it. If you have any questions, you share it with the Dean sir and ma'am, and then I'll try to answer them as much as possible. Sure.
Thank you, sir.
Thank you so much for your presentation, sir.
Yeah. Thank you. Good night.
Thanks for your support and cooperation.
Yeah.
I
Same here.
invite you to validation function, sir. Kindly you accept my invitation to join the validation section, sir. Coming in.
Sure. I'll see. Yeah.
Thank you so much, sir.
Thank you. You have a good day. Bye bye.
Yeah, thank you. Thank you so much.
Thank you all for your attention. And looking forward to welcome you all tomorrow with the same cooperation. Thank you all. Thank you, participants.
Thank you, madam. Thank you all.
Okay, close பண்ணிக்கலாம்.